Welcome to session 2 of the preview videos. This one is going to deal with graphing linear, exponential, absolute value, and piecewise functions. A scrap sheet of graph paper or graph paper that you can glue into your vocab notebook might be beneficial. When we talk about all of these types of graphs, remember that our job is always to get y by itself first. So beginning with the most basic and the one that we are very, very good at is the linear functions. If we start out with an equation that looks like this, 2x plus 8y equals negative 24, remember you want to get y by itself. Once you get y by itself, it's in the y equals mx plus b form. M stands for the slope, which is where you move. And B represents the y-intercept, B for begin. So there's two ways that we can graph this. We can start by graphing the y-intercept and then doing a slope that it represents negative 1 over 4, which means rise to a negative 1. That actually means go down 1 and to the right 4. We continue our points. This graph didn't continue our points, but please remember to continue your points throughout the entire graph. The other way to do this is to do this in your graphing calculator. Please remember your steps for graphing. When you go home, you hit your graph page and you can type in the equation. The equation that you type in, though, has to be this equation that's where y is by itself, not the original. The second type of graph that we've discussed are exponential graphs. And an exponential graph has an exponent of x. Remember, that was very repetitive for us, so that's kind of how we remembered it. Definition of an exponential function is a function that has a variable that's the exponent. The general format, remember we saw this at geometric sequences as well. Starting value is the y-intercept, that's the a, and then the b is how much it grows, the growth factor, and the x is the exponent. Notice the difference between a linear and an exponential graph. An exponential graph curves and kind of grows very quickly, whereas a linear has a constant rate of change. Another type of graph that we talked about was the absolute value graph. Remember, we had parent functions. We're going to talk about the parent function of a quadratic a little bit later on. But for now, the absolute value parent function, you can find this graph by, again, making a table in your graphing calculator. This particular picture also reviews the words domain and range. Remember, domain are the x values. So in this particular case, the domain goes from negative infinity all the way to positive infinity. The range deals with the y values. The y values is how tall the graph actually is. So if you're looking right here, starting way down here at negative infinity on the y, you go up, there's nothing, 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 and then as soon as you hit 0, the graph begins. So this range actually goes from 0 to positive infinity. We've talked about, or we should have talked about by the time we hit this review session, some transformations. When you have a plus inside of an absolute value, it moves the picture left or right. It's kind of backwards. If it's a plus 2 inside, then the vertex moves to the left. If it's a plus 1, it moves to the left 1. Whereas if there's a minus outside, or inside, then it moves to the right 3 or right 1. There are some practice ones if you'd like to do some practice ones right in your notebook right now. Remember, the addition or subtraction inside the absolute value tells you left or right. If there happened to be an add or subtract outside, it would tell you an up or down. So if this had x plus 2 inside, but then over here it had like a minus 1, then the vertex would actually move down 1, and it would also move to the left 2. So be careful with that. Always remember, please, to make sure that you're putting a table, and when you do your table, you show the table, particularly on the regions. Really important that you're showing some work, even though your calculator does most of it. Remember, again, please pause the video if you need to write down all of this stuff. and draw some sketches. Piecewise functions was another topic that we discussed. Piecewise functions are parts of several graphs with specific domains. So if you look right here, this is a linear picture and a quadratic picture. But I only want the line to show where x is -2 or less. So right here is where x is -2. So on my table, I would only care about the points that go this way towards the left and anything less than or equal to -2, which is why it's a solid dot. In this particular case, this is a parabola. I only want the parabola where it's bigger than -2. So even though that's already solid, if it was just the parabola, it would be open. You graph only those points that matter. These dotted lines are really invisible extensions of each of those two graphs. Again, we're talking about reviewing domain and range. The domain, there's arrows on both ends. So the domain goes from -infinity to +infinity, and actually so does the range. This piecewise function has three different problems. Okay, so it has a linear where where x is less than -2, so the line like this is only where I want it less than -2. Notice that's an open dot. Then the quadratic, I only want graphed from -2 to +1. So on my table, I only care about those points from -2 to +1. And then the final one, y = 2, that's just a line straight across. But remember, I only want it where it goes greater than or equal to 1. Pieces of three different graphs. The same thing with this right here. Now in this particular case, if we look at this, the x values, it goes on and on forever in both directions. So the domain is -infinity to +infinity. But check out the range. There's no graphs, nothing about the graphs below this point, below this point, below this point, and then suddenly we hit -2 on the y. So the range is -2 all the way up to infinity. So it's important to remember all those things. Again, pause the video anytime that you need to make these notes. And the final type of graphing that we did was inequality graphing, almost exactly the same as linear, except we have to remember to shade. Notice right here, this line, we'd have to get y by itself. When you get y by itself, the y-intercept is going to be somewhere kind of between 2 and 3. And the slope, it looks like the slope is something like, let me see, -1/2 maybe, a -1/2. When we graph this, it's dotted. Notice that the dashed line is dotted because there's not an equal to. Then over here, in order to figure out how you shade, they plugged in 0, 0. So whoever did this likes my favorite point as well. You plug this in, and 0 is in fact less than 10. It's true, you shade towards. Another example, again, same thing. And again, please notice that this is solid. That should have an equal to underneath it. Oh, it does. So we have an equal to underneath it. Solid line. Notice that the y-intercept is -2. The slope is 1/1. Again, this person did not choose my favorite point. This person chose 5, 0. You plug in, and it's true towards 5, 0. If we used my favorite point, 0, 0, they did this one over here, it's false. False means you shade far away. So when it's true, you shade toward. When it's false, you shade far away. Have a great day.